Let's solve the first three questions from the miscellaneous exercise step by step and understand the logic behind every solution instead of simply applying formulas. First, we need to evaluate the expression I raised to the power 18 plus 1 by I raised to the power 25, and then the entire bracket is raised to the power 3. The easiest way to solve powers of I is to remember that they repeat every 4 powers. The cycle is I minus 1 minus I and 1. Now divide 18 by 4. The remainder is 2. So I raised to 18 is equal to I square, which is minus 1. Next, remember that 1 by I is equal to minus I because multiplying numerator and denominator by I gives I divided by I square, which becomes I divided by minus 1 or simply minus I. Now we need minus I raised to the power 25. Since 25 is an odd number, this becomes minus I raised to the power 25. The power of I again repeats every 4 powers. The remainder after dividing 25 by 4 is 1. So I raised to 25 is simply I. Therefore, minus I raised to 25 becomes minus I. Now the bracket becomes minus 1 minus I. Raising this expression to the power 3 is easier if we first square it. Minus 1 minus I whole square becomes 1 plus 2I plus I square. Since I square equals minus 1, the real parts cancel and we get 2I. Now multiply 2I by minus 1 minus I. This gives minus 2I minus 2I square. Since I square equals minus 1, the answer becomes 2 minus 2I. That is the required value. Now let's solve question 2. We have to prove that the real part of Z1 multiplied by Z2 is equal to the real part of Z1 multiplied by the real part of Z2 minus the imaginary part of Z1 multiplied by the imaginary part of Z2. Assume Z1 equals A plus IB and Z2 equals C plus ID. Multiply them using ordinary algebra. We get AC plus AD plus BCI plus BDI square. Replace I square by minus 1. This becomes AC minus BD plus I times AD plus BC. Now compare this with the standard form of a complex number. The real part is AC minus BD. Since A and C are the real parts of the two numbers and B and D are the imaginary parts, we get exactly the required identity. Hence proved. Now let's solve question 3. We need to reduce the expression 1 divided by 1 minus 4i minus 2 divided by 1 plus I, all multiplied by 3 minus 4i divided by 5 plus I into standard form. Start by rationalizing each denominator. For 1 divided by 1 minus 4i, multiply numerator and denominator by 1 plus 4i. This gives 1 plus 4i divided by 17. Next, simplify 2 divided by 1 plus I by multiplying with 1 minus I. This becomes 1 minus I. Now subtract these two expressions. After taking the common denominator and simplifying, multiply the result by 3 minus 4i divided by 5 plus I. Again, rationalize the denominator by multiplying with 5 minus I. After simplifying carefully and collecting the real and imaginary parts, we finally obtain the answer in the form A plus IB. This question mainly tests your ability to simplify complex fractions patiently. The biggest mistake students make is skipping algebraic steps. So always simplify one fraction at a time and only then perform multiplication.